If an object's being pulled up a ramp, our direction of motion is now this way. Okay? And so 2 new words to us, but not to us, is this symbol here. This means perpendicular. And this symbol here means parallel. And we're always talking to the surface. So remember yesterday I said I'm going to start being very specific in my language, and that force of gravity always works towards the center of the object, whereas force normal is always 90 degrees to the surface. Okay? So if we have this object and our direction of motion is up, we're going to still have this force applied going this way. The opposing force of force applied is force of friction. So it's going to go this way, downhill. Remembering the language, force normal, I'm just going to turn my paper, is always 90 degrees to the surface. So this is force normal. Okay. And remembering that force gravity always works straight down towards the center of the Earth. This is actually force gravity here. So now we got a new angle. Okay? And when we look, at this piece, we're like, okay, we need to extend our, with force gravity, it's not 90 degrees, it's not parallel, it's different. So we need to make it like this. We need the 90. Force normal needs an opposing force. So we call it force gravity and we put the parallel symbol behind there. Okay, you probably can't see it very well. Okay, force gravity parallel. And then we also then are going to have, or no, sorry, not parallel. That's my bad. This is perpendicular, right? Because here's the 90 degrees to the surface. This is force gravity perpendicular. And then we have this force here. Here's a pencil. And this is force gravity parallel. I'm not perfect, but parallel to the surface. This is force gravity parallel. Because we can't, what do we do with that guy, right? So now we have a parallel and we have the perpendicular. I'm going to make this a little more parallel. Okay, so we got lots going on. In the horizontal, or in the, let's not call it horizontal more, let's call it parallel. In the parallel direction, what forces do we have? What's the force that's going in the same direction as the direction of motion? Force applied. What's the opposing force of force applied? Right. So plus negative force of friction. And now we need to look at these pieces down here. What else is in that? Same parallel motion. There's within these three here, force gravity perpendicular, and force gravity parallel. Which one would fit in this parallel force net equation? This one here? This fits in this direction of motion? Which one of these three is in this same direction of motion? Force gravity parallel. Now, the question is the force gravity parallel in a positive direction? Is it going in the same direction of motion, or is it an opposing force? Which way would gravity go? If I was going this way, which way would gravity go? Opposing. Okay, so now it's looking at all of those different pieces. What about force net in the perpendicular? What forces do we have? What's in the positive direction for this force? Force normal. What is the opposing force, excuse me, of force normal? Force gravity parallel or force gravity perpendicular? Okay. Now, is this box levitating or going through the surface? No. So there is a balanced force. Which means that force normal then is going to be equal to force gravity perpendicular. They have to be equal. It's not levitating, so force normal isn't bigger. It's not going through the ground. Force gravity isn't bigger. They have to be equal. Okay? So this is where this very last lesson in this whole unit becomes a lot more intricate. Okay, let's give it a whirl. A boy on a toboggan is sliding down a snow-covered hillside. The boy and the toboggan together have a mass of 50 kilograms, and the slope is at an angle of 30 degrees to the horizontal. Find the boy's acceleration if there's a frictional force of 64 newtons. So first things first, we have to draw a picture. The boy is going down a hill on a toboggan. Okay? Let's just, without doing any information, let's just draw in the forces at play. Is there a force applied? Why do you say no, Daniel? Yeah, the toboggan is just going down the hill. Nobody pulled that toboggan down the hill. Nobody pushed that toboggan down the hill. The toboggan is already in motion. So there's no force applied. What is there an opposing force though? Say yes, Cameron. What force would you say is the opposing force? Force of friction. right? You get on that toboggan, the snow is going to act against the plastic slide that you're on or the wood slide that you're on. I mean, you go, there's very little, the coefficient's very low, right? Just like curling rocks, they go forever, but eventually they stop. Toboggan eventually stops, or you crash, or you hit a fire hydrant. That sounds like a story. I hit a post on the backstop in the ball diamond because the dare was to see how close you could get to the backstop. And we had one of those old-fashioned wooden ones that curled up, and my feet got stuck in there and I couldn't bail out, so I hit the backstop. I won. I got close. Yeah, I won the dare. I couldn't walk, but I won the dare. Okay, what is this? Is the sled, well, I guess we could be, but is this sled levitating or going through? The answer is no. I mean, we've all caught air on a toboggan, but the answer is no. So force normal is always going to be perpendicular to the surface, right? Because our direction of motion is this way. What is going to be the opposing force for force normal? Oh, very close. Let's do force of gravity first. That one always exists. Otherwise, we would be up floating in the space. But let's look at this, Daniel. The opposing force, it's perpendicular to the surface. So it'd be force gravity perpendicular. You had said parallel. Or maybe you didn't. Maybe I misheard you. Okay. What is the other force of gravity then is going to be this way, parallel to the surface. And which way do we think that force of gravity is going to go? Is it going to go up the hill or down the hill? Which way is our direction of motion? It's down the hill. Gravity is going to always pull us down, right? So the force of gravity is actually this way. It's important that you identify that particular direction because you need to know, is it in line with the direction of motion or is it opposing the direction of motion, which will tell you it doesn't need a positive sign or a negative sign. Okay, we've identified all of those pieces. Now let's go back to the question and identify the numbers and where they go. So we have a mass of 50 kilograms. And the slope is at an angle of 30 degrees to the horizontal, which means that this angle here is 30 degrees. This one here, because here's the horizontal surface, and it's 30 degrees to this. Actually, I got that wrong, but it is 30. That will be 30. If I extended this out and made a big long triangle, this one here is 30. That's 30 degrees to the horizontal, right here. If this angle here is 30 degrees, this part of the triangle here is 30 degrees. And that's your math 30. That's, like, I understand it, but you guys get way more learning from Mrs. Johnson than what I give you. All I tell you is this angle here to the horizontal is the same angle right here of force gravity to the surface. Okay? And it said that the force of friction was 64 newtons. All right. The question is asking us to solve what? Acceleration. Acceleration is equal to what? Force net over mass. Okay, we have mass. Do we have force net? Nope. Which force net do we need? Do we need a parallel or a perpendicular force? Parallel, right? We want it to go with the surface that the boys are sliding on. So we've already said that there is no force applied because the boys are already in motion. And so what is the positive force that's going in the same direction as the direction of motion between these 5 forces? Parallel. And what is the opposing force? Force of friction. Negative force of friction. Okay. Well, do we have force gravity parallel? Nope. Can we find force gravity parallel? We can. Force gravity parallel is going to be using some trig. It's going to be looking at force of gravity times by, if I had this value, if this is my hypotenuse, because all I've done is I've turned my triangle up and down. Force gravity parallel, is it adjacent or opposite of the 30 degrees? Force gravity parallel, opposite. So it's going to be the sine of 30. And so force gravity, true force of gravity, is mass times acceleration due to gravity. So 50 kilograms multiplied by 9.81. And what do we get for a value? Do we agree with Daniel? Because I got a, oh no, I agree with you. 490.5. When I go to figure out force gravity parallel, then I'm going to go the sine of 30 times 490.5. And I get what? What'd you get, princess? we get for a value? What would be the opposing force? If force gravity is working straight down, we would call this one here opposite of force normal, force gravity in the perpendicular. Okay? The other one that we need to consider is the one that's running parallel to the surface. Force gravity parallel. And one thing to remember, if this angle here is 35, that means that this angle here is also 35. Pardon me? How do we solve for coefficient of friction? There's only one formula. Perfect. This is how we're going to solve this problem. This is what we're looking for. Now, when we look back at this question, we have force applied is 46 newtons. We have acceleration is 2.6 meters per second squared. And we have mass is equal to 4.5 kilograms. Okay, so we have all those different pieces of information. Right now, none of those come into play in our formula. We don't have acceleration or mass in here. So we need to start fanning out. How are we going to solve for force normal? Force normal is working in which direction? Perpendicular or parallel? Perpendicular. And in that perpendicular motion, what is working in a positive direction? Force normal. What is the opposing force of force normal in our diagram? Right. Force of gravity perpendicular. Now, we said this box isn't levitating or going through the ground, which means that the force net is balanced. When our force net is balanced, it means that force normal is equal to force of gravity perpendicular. Right? They have to be equal to each other. One isn't stronger or weaker than the other. So, we're looking for force normal. Force of gravity perpendicular. How are we going to figure that piece out? How would we solve for it? Okay. So we got the cos 35 part. What about the force of gravity? Force of gravity is equal to mass times acceleration due to gravity. So we're going to go 4.5 times 9.81. I'm going to stop there for right now, and I'm going to look at the other side of the equation over here, because we're going to be able to now get back up. Right here, we're going to solve for force gravity. Once we solve for force gravity, we'll be able to solve for, this is force gravity. then we can solve for perpendicular, then we can solve for force normal. What about force of friction? Which force, parallel or perpendicular, force net, are we going to find force of friction in? Force parallel. And so what is the force that is going in the same direction as our direction of motion? Force applied. What is moving in the opposite? What is the opposing force for force applied? Force of friction. And there's another one. I see some head nodding. Which one would that be? What is also an opposing force in the parallel direction? Yeah, force gravity parallel, right? This one here is moving in the same direction as the force of friction. It's an opposing force. So we can't forget it. Now, we have force applied. Force gravity parallel, we don't have. How do we solve for that? And then the force of gravity is going to be mass times gravity, which is 4.5 times 9.81. Force, so that's going to take care of this line. What about force net? Parallel. We don't have that number. Can we solve that number? Yes, we can. Force net parallel is going to be equal to, what's the base formula for force net? Mass times acceleration. And we have 4.5 kilograms multiplied by 2.6 meters per second squared. Now we can start going back and filing back up the columns and doing the reverse math. So I'm just going to start on the left-hand side, and I'm just going to work across each tower. So force net is going to be equal to 4.5 times 2.6. So force net parallel is equal to 11.7 newtons. Force gravity parallel is going to be equal to the sine of 35 times 4.5 times 9.81. So force gravity parallel is equal to 25.32 newtons. When I want to isolate force of friction, how do I rearrange this equation to isolate for force of friction? What do I need to do? It's negative here. So how do I move it so it's positive? What's the opposite math function? Addition. So I'm going to have force of friction is going to be equal to force applied plus, should be negative in here, negative force gravity perpendicular. How do I move this guy over? Minus force net in the perpendicular or parallel. So that's this part here. Now I'm going to work on this side over here, the perpendicular side. And I'm going to go force normal. Is equal to 44.145 applied by the cos of 35. Okay, so now I have my force friction. I have my force normal. Now I can go back to the very original question, force of friction is equal to U force normal. And I get 0.24831. Somebody else get that? But we got to go back to sig digs. What would our sig digs be? 2. So U is equal to 0.25.